Alright, today we're going to learn a different way of solving systems of equations, and this is the final strategy we'll learn for solving systems. We've already learned to solve systems by graphing. We learned how to solve systems with substitution, and today we're going to learn how to solve systems with elimination. So the goal of elimination is to try and eliminate or get rid of one of the variables. And so the steps that we're going to follow to do that are to make sure the equations are lined up. That's our first step. So we want to make sure the equations are lined up with each other so that we can actually get rid of a variable. Next, and we'll get into this in some later examples, but if needed, we're going to multiply or divide to get an inverse coefficient, and that'll make a little bit more sense in just a moment. Once we have this inverse coefficient, we're going to add the equations to eliminate the variable with the common coefficients. And we're going to solve for whatever remaining variable we have. So in step 3, we're getting rid of a variable, and then in step 4, we're solving for whichever variable is left over. Once we've solved for that variable, we can then substitute that answer into an original equation to solve for the other variable, the one that we eliminated in step 3. So these are a lot of directions, but they'll make sense once we work through some examples. So this first one is about as straightforward as it gets. If we look at step 1, we need to make sure the equations are lined up, meaning that we want our x's with x's, and sure enough they are right here. We want y's with y's, equals with equals, and then we want these numbers on top of each other. So this one is already good to go, they're lined up. Also, we want to check and see, we're looking to see if when we add these equations together, the goal is that one of the variables will be eliminated. And this one is already ready to go because we have a negative 3y here, and we have a positive 3y. So when we add these like terms together, these are actually going to cancel each other out. So I'm going to go ahead and start solving this one, or eliminating this variable. So what we do is we add our like terms. So this is 1x plus 3x gives me 4x. Then I have negative 3y plus 3y. These cancel each other out. So I'm left with 4x equals, and then I do 7 plus 9, which is 16. Now the x is almost by itself. I just divide both sides by 4, and I'm left with x equals 4. So I was able to solve for my first variable x, but I do need to go back and substitute this into one of the equations in order to solve for y. So it doesn't matter which one I use, I'll go ahead and plug it into the first one. So I have, instead of x, I'm going to put 4 minus 3y equals 7. And I'm going to get the y by itself now. So I'm going to subtract 4 from both sides, get negative 3y equals 3. When I divide by a negative 3, I get y equals 1. So now, just like when we solve any other system, we're going to express our solution as a ordered pair. So I have 4, 1. Oh, I made a mistake there. I should have divided by a negative 3 here. I should have gotten a negative 1 for my y value. There you go. 4, negative 1 is my final answer. All right, so we're going to move on to this next one. And right away I see that step 1 has actually not been completed for me. The equations are not lined up. I don't have x's on top of x's. This first one is in the form, usually we want these in the form ax plus by equals c, or in other words, we want to have our x's, our y's equaling a number, okay? And the first one is, we have x, 2x minus y equals 6, okay? The second equation, though, is in y equals form. So what I need to do actually is move the 3x to this side so that it's on the same side as the y, and I'll be left with just 4. So I'm going to rewrite this completely. The top equation 2, it's going to stay exactly the same. And when I rewrite this one, I'm going to put the 3x first so it's lined up, plus y equals 4. Now they're lined up, and I want to pay attention to see which variable is going to get eliminated here. And it looks like I have a negative y and a positive y, which are going to cancel each other out right here. So that's what I'd want when I'm using elimination. So now I'm just going to go ahead and add these two together. So I have 2x plus 3x, which gives me 5x. Negative y plus y cancels. 6 plus 4 is 10. So I divide both sides by 5, and I get x equals 2. Now that I've solved for one variable, I can plug this value in to any equation to solve for y. I'm going to go ahead and use this one since the y is already by itself. I get y equals 4 minus 3 times 2, because I'm plugging it in for x. Then I get y equals 4 minus 6, so y equals negative 2. Now I am going to write my final answer, like 2 comma negative 2. All right, now we're going to look at some examples where the second step is going to be needed. We are going to need to do some multiplication in order to be able to eliminate a variable. So you'll see what that means in just a moment. So I'm going to look at number 3. And number 3, they are lined up. I have x, y number, x, y number. So these are lined up, but if you notice, I don't have an inverse coefficient. So I have x and 4x. Those aren't going to cancel each other out. I have 10y and 5y. Those won't cancel. So it looks like we can't use elimination here. And, you know, in the future, when you're solving a system, you could go ahead and do something else at this point if you wanted to. But you can still solve this by elimination. You want to look for some way to get an inverse coefficient. So it looks like, as far as the x's go, they're both positive. I have a positive 1 and a positive 4. So what I could do is I could multiply this top equation by negative 4, which would turn this into a negative 4. And that would work. But I could also, maybe an easier way would be with the y's, I have 10y and then I have positive 5y. If I multiply this by negative 2, I'll get a negative 10, which would eliminate with the 10 up here. But remember, anytime I multiply, I have to do that, multiply the entire equation by whatever I'm multiplying by. So if I want to multiply 5y by negative 2, this entire equation needs to be multiplied by negative 2. And this should work. So I'm going to rewrite the top one, will not change at all. So I'm going to write x plus 10y equals 3. But this bottom one, I'm distributing this negative 2 to everything inside the parentheses. So I have negative 2 times 4x, negative 2 times 5y, and negative 2 times 5. So I'm going to go ahead and do that multiplication. So negative 2 times 4x is negative 8x. Negative 2 times 5y is negative 10y, which is what I wanted. Equals negative 2 times 5 is negative 10. Now I should be in good shape to add these together. So that the 10y and the negative 10y will cancel each other out. So I get 1x minus 8x, which is negative 7x. These 10y's cancel, equals 3 minus 10 is negative 7. So I divide both sides by negative 7, and I'm left with x equals positive 1. Now that I've solved for one variable, I'm just going to plug in the x into the other one of the equations and solve for y. So I'll plug it in to this equation right here. So I have 4 times x, which is 1, plus 5y equals 5. So I get 4 plus 5y equals 5. I'm going to subtract 4. I get 5y equals 1. And I divide by 5. And I get y equals 1/5, which is okay. So now I write this as an ordered pair, 1 comma 1/5. And that is our final answer for this one. All right, so number 4 is another one where we just need to take a look. I have 3x minus 2y equals negative 7, 2x minus 5y equals 10. Now once again here, I have 3x, 2y, those aren't opposites, and 2y and 5y are also not opposites. So I'm going to need to do some multiplication here. So I want to see which one would be the easiest to get rid of. Well, 2 can't multiply to 3. and this 2 can't multiply to 5 either. So in some cases, like this one, you're going to have to multiply both equations in order to get what you're looking for. So that means I could multiply this 2 times 3, and I would get 6 here. And I could multiply this 3 times negative 2, and I could get a negative 6 here, and that would cancel. You could also do the same things with the y's. It's worth pointing out that I could multiply this by negative 5, and I could get positive 10, and I could multiply this by 2, and I could get 10. So it doesn't really matter which way you do it, just whatever you're most comfortable with. And you're trying to get an opposite, an inverse coefficient here. So I think I'm going to work with the x variable. So that means that I need to multiply this first one by negative 2, and I'm going to multiply the second equation by 3. So up here I'm going to get a negative 6, and here I'll get a positive 6. So I'm going to rewrite both of these. So in the first one, when I distribute, I'm going to do negative 2 times 3x, negative 2 times negative 2y, and negative 2 times negative 7. So I'm going to go ahead and multiply those out. So negative 2 times 3x gives me the negative 6x that I'm looking for. Negative 2 times negative 2y becomes a positive 4y. And negative 2 times negative 7 becomes a positive 14. Now down here I'm going to distribute. I'm going to do 3 times 2x, 3 times negative 5, and 3 times 10. So 3 times 2x gives me a positive 6x. 3 times negative 5y is negative 15y. And that's equal to 3 times 10, which is 30. All right, that took a little bit of work, but now I have my opposite coefficients, my inverse coefficients, negative 6x and 6x, which is what I was looking for. So now I'm going to add these equations together. These cancel and give me 0. 4 minus 15 is going to be a negative 11y equals, and then I have 14 plus 30, which is 44. Divide both sides by negative 11, and y equals negative 4. All right, now I just need to substitute this in to solve for x. I'm going to go ahead and plug this in here for y. So I get 2x minus 5 times negative 4 equals 10. Now I need to multiply these two together first. So I get 2x. Negative 5 times negative 4 is a positive 20 equals 10. I subtract 20 from both sides, and I get 2x equals 10 minus 20 is negative 10. When I divide both sides by 2, I get x equals negative 5. Now that I've solved for x and y, I just plug them in to my ordered pair, and I get negative 5 comma negative 4, which is my final answer. Okay, so now we're going to do a couple word problems, solve them using elimination, and I think you'll see that these are not too hard to set up or to solve. So in this first one, it says that the sum of two numbers is 70. Sum is a word that means we're adding. We're talking about two numbers, we don't know what they are, and they equal 70. And their difference is 24. Difference is a word that means we're subtracting. It's asking us to find the numbers. So if I'm trying to solve for two numbers, that means I need two equations. So the first equation, I'm going to be adding these two numbers together. Now, I need to come up with a name for these two numbers, so I'll just use x and y. So at first, I know that the sum of these numbers, so x plus y equals 70. And then it tells me that there, meaning the numbers, difference is 24. So that means if I take x minus y, it equals 24. And now I can find the numbers using the system. So previously we solved one similar to this using substitution, but I think you can see now that it's actually pretty straightforward to solve this using elimination because I have a positive y and a negative y, which will cancel if I add these together. So I have 1x plus 1x, which is 2x. Y minus y gives me 0. equals 70 plus 24, which is 94. I divide both sides by 2, and I get x equals 47. That is my first number. Now I can take this and plug it back in to one of the equations. I'll plug it in here. So I get 47 plus y equals 70. Subtract 47 from both sides. And I get y equals 23. All right, now we want to answer the question. It says find the number. So instead of writing my answer as an ordered pair, I'm just going to answer the question. So I'm going to say the numbers are 47 and 23. All right, now I'm going to go to number 6, which is another word problem. It says, at Giovanni's Pizza, a drink and 2 slices of pepperoni pizza cost $10.25. If you buy 4 slices of pepperoni pizza and 1 drink, you will pay $18.75. What is the charge for 1 drink and 1 slice of pepperoni pizza? Okay, so in this situation, we're basically trying to find the cost per slice and per drink, and they're giving us 2 different orders. In the first order, someone bought a drink, meaning 1 drink, and 2 slices of pizza. So if we let drink be D and pizza be P, we can write an equation here. So 1 drink plus 2 pieces of pizza equals $10.25. That was the cost. And the second person, they also got 1 drink, but they got 4 pieces of pizza, and they spent $18.75, which makes sense. They got more pizza, so they spent more money. So now we have 2 equations. We're trying to solve for 2 things, drinks and pizza, and so we're going to go ahead and solve this using a system. So in both cases, only 1 drink was ordered, but these are both positive. So if we're going to try and eliminate one, we actually need to multiply one of these by a -1. So I'm going to rewrite. I have 1d plus 2p equals 10.25 on top. On bottom, I'm going to distribute a -1. So I get -1d minus 4p equals -18.75. So now when I go to solve this, switch colors here. I'm going to add these together, so I have 1d minus 1d cancels, 2p minus 4p is 2p, equals, and then I need to do 10.25 minus 18.75. That gives me -8.5. So now I just divide both sides by 2, and I get p equals -4.25. Now, you kind of want to use your brain here. A piece of pizza can't be negative. The reason this turned negative is because I multiplied this by a negative number. So the cost of the pizza is not actually -4.25, but it's actually +4.25. So p actually equals 4.25 positive. Okay, so now that I have p, I can go ahead and plug that in to one of the original equations, and I can solve for the cost per drink. So I'm going to do that. I'm going to use 4.25, and I'll just go ahead and plug it into this one right here. So 1d plus 4 times 4.25 equals 18.75. So I need to multiply 4 times 4.25, and I get 17. So d plus 17 equals 18.75. So if I subtract 17 from both sides, I get d equals 18.75 minus 17 is 1.75, or $1.75. Okay, so the charge for 1 drink is, and we can go ahead and kind of add our units here, a drink is $1.75, and a piece of pizza is $4.25. So that is my solution.